Good evening, everyone. Welcome, all of you. Very good evening, guys. Very good evening to all of you. So, in today's session, guys, and more upcoming session, we are going to complete 70 important organic and inorganic questions for your upcoming CSIR NET preparation. So, 70 important previous year questions we are going to do for the organic and inorganic chemistry. So, this is a revision series. Yes, very good evening, all of you guys. And from now onwards, guys, the timing is going to be 6 p.m. for the YouTube session. Okay? So for the YouTube session, once again repeating guys, the timing has changed. So अभी हमारा usually timing था 9:15 a.m. in the morning, but the time has changed to 6 p.m. For the YouTube, and you are going to have regular sessions on Thursday, Friday, and Saturday. All right, 3 days of the month you are going to have, 3 days of the week you are going to have regular YouTube session, Thursday, Friday, and Saturday, right? So yes, we want to complete maximum practice questions before your examination, so that's why we are doing this practice everywhere. ठीक है, तो YouTube पे भी practice करेंगे guys, and already you know Battle of Pole series is going to start from 4th of September. If you have not visited my profile, please do on Unacademy and just register for the free classes. ठीक है, ये सब free classes हैं which I'm talking about, Battle of Polls and YouTube session, right? So yes, please register. Also, if you want the notification or the link for each and every session on time, then you can join my Telegram channel CSIR NET 2022 for all the important links on time. Okay guys, and one more very important thing guys, कि अभी जिनको already मैंने बता दिया है वो join कर ही लेना, जिनको नहीं बताया है guys, 5th of September we are going to have a live event on Unacademy. Okay, so the link for the live event will be there in the description, or I had also pasted the link in the Telegram group for this live event. All right, on 5th of September, and your favorite celebrities are also going to be there, like Gaurav Taneja and many more. If you like really like comedy, then Tanmay Bhatt is also going to be there. All right. So after 6 p.m. you can definitely join up over there just for a little bit of change in the mood. ठीक है. Chalo, good evening. Yes, good evening all of you. Now let's start our practice guys. Most important questions we are going to do. ठीक है? So yes, this is our question number 1. Major product X based on the preferred conformation in the reaction is. Yes. First question है, बहुत simple question है, but if you have not done fragmentation, this question is a reminder to you कि fragmentation करना बहुत ज़रूरी है. All the kinds of fragmentation, and you can get these example in Claydon chapter number 36. मैं आपको ये भी बता रही हूँ what to do now. If you have not studied this, Claydon chapter number 36, look for the fragmentation reactions. Yes. All right. So, what is going to be the answer? You can message in the live chat. Yes. So, basically, guys, what do you have over here? See, you're having a hydrogen on the top, you're having a OH like this and OTS in this way, right? So in the presence of H minus, right, it's going to deprotonate the hydrogen over here, right, and it's going to become O minus. What is the O minus going to do? It's going to fall on this कार्बन ऑक्सीजन बॉन्ड, ये क्या बनाएगा? डबल बॉन्ड बनाएगा. एंड विथ रेस्पेक्ट टू द ओटीएस, ओटीएस इज अ लीविंग ग्रुप, आपको पता है ओटीएस इज द लीविंग ग्रुप, राइट? सो व्हाट आर यू गोइंग टू लुक फॉर? एक बॉन्ड जो कि इससे एंटी पेरिप्लानर हो. The anti-periplanar bond is going to break, isn't it? Yes. So when the anti-periplanar bond is breaking, तो जैसे कि ये मॉलिक्यूल है, फॉर एग्जाम्पल देयर इज गोइंग टू बी द डबल बॉन्ड एंड देयर इज द C double bond O over here. ठीक है. So the answer is you are getting a transalkene, not a cisalkene. This is wrong and absolutely it is fragmentation. तो ये दोनों तो वैसे भी गलत है. This question is very very easy because the question is very obviously telling you that it is fragmentation and C and D are absolutely wrong. It is not a simple elimination reaction. Anti-elimination तो बिल्कुल भी नहीं है because OH is not a good leaving group. Okay, so it is fragmentation. If you just know how to draw the trans-decalin system, you can very easily say it is transalkene. ठीक है? Very good, all of you. First question done. Let's look at question number 2. Yes, are you able to see the question properly? This one? Yes, guys, for those who are joining now, guys, welcome all of you. Good evening, and let me inform you once again. Thursday, Friday, Saturday, 6 p.m. is the new time for the YouTube sessions. ठीक है, अभी नया time हो गया है 6 p.m. का. Yes. Okay, absolutely. ये देखो, what is this question asking you? See, in the reaction, major product X and Y, तो दोनों ही major है, कोई बात नहीं. But what is important? Position of the isotopic carbon. So it's a simple rearrangement reaction, not a problem. लेकिन rearrangement करने के बाद कार्बन किधर जाएगा? Yes. Alright, so which rearrangement is this, guys? By the way, what would you say about it? This one is star marked. Yes. Paraclasin, absolutely very good. Yes. Paraclasin में क्या क्या होते हैं? कौन से reaction होते हैं paraclasin में? Yes, it is paraclasin. But what reactions are involved in the paraclasin? Yeah, first of all, it is going to be a simple Claisen rearrangement. So let's see how a simple Claisen rearrangement is going to be. ये देखो, 1, 2, 3, 1, 2, 3, 3 sigma tropic rearrangement, which is a Claisen rearrangement. 3 sigma tropic, लेकिन Claisen rearrangement that is going to give you this product. Yes, that is going to give you this product. So are you directly going to do the enolization? नहीं, अभी नहीं करना है enolization. You will do one more rearrangement, that is once again 3 sigma tropic cope rearrangement this time. ठीक है? So 3 sigma tropic cope rearrangement, उसको करने के बाद में you are going to do the enolization. These questions, guys, they have been asked so many times. ठीक है, कितनी बार आ चुके हैं ये, right? That is Claisen followed by cope, followed by enolization, followed by manic, फलान ढिकन. So ये सारे question हमेशा आते हैं, Claisen, cope, manic in sequence, right? Very very important. So you can do one thing, you can do the enolization, that will give you one product, and you can just do one more cope rearrangement, that will give you one more product. ठीक है? So let's say we are doing the cope rearrangement. After that you get this thing. After that you will get this thing. So ये देखो, where is the star mark carbon? Did we forget this? ये देखो, first case में, guys, after you are doing the rearrangement, the star mark carbon ends over here. This is your isotope. ये इधर आ जाएगा after the first 3 sigma tropic rearrangement. When you are doing one more 3 sigma tropic rearrangement, it is going to go back over here, isn't it? So this is one of your major products. This is one of your major products. ठीक है? And after enolization, what are you going to get, guys? Enolization करने के बाद में you are going to get something like this. Yes or no? Absolutely. Isotopic labeled carbon. is over here. एक आ गया product ये, let's say this is Y. One more product you will get guys, मैंने बोला था यहाँ पे enolization मत करो, we have to do one more sigma topic. Let's say but we are doing enolization, तो क्या होगा? Let's say we do enolization in this step, in this way, then you might end up with one product. How is that product going to look like? If you directly do enolization, that product is going to look like this. So this is our answer. So you are getting X and Y, both of them are major. Both of them are major. The possibility is only when you are doing the rearrangement at one time and the other time, like 3 sigma tropic, दो possibility है, दो back to back reactions है. Very nicely answered all of you. Look at next question, question number 3. In the two-step reaction sequence, now this is based on the amino acids, proteins. The major product Y is going to be, now see guys, in the natural product specifically for amino acid, ज़्यादातर question किस पे आते हैं? Sequencing पे. So what are the different types of sequencing methods that you must revise and practice questions? They are very scoring. आपको आ जाएगा ये आराम से, 4 marks आराम से आ जाएंगे if any question comes like this. Yes. So what are you looking at? This is 2,4-DNFP, isn't it? 2,4-dinitrofluorobenzene. 2,4-DNFB. 2,4-dinitrofluorobenzene. ठीक है. What is going to happen? In the presence of a mild base, the nitrogen with the lone pair is going to do the SNAR mechanism. ठीक है, ये हो गया SNAR mechanism. It is going to replace the fluorine and nitrogen attacks over here. ठीक है, it is a dipeptide, nitrogen gets connected, but it is used for N-terminal cleavage. N-terminal cleavage के लिए use होता है. All right, no problem. So for the N-terminal cleavage, let's say it is attached. After that, you are going to hydrolyze the peptide or the amide bond. Peptide bond break करने के बाद में what are you going to get as the major product? So you might think कि ये वाला जो portion है, कई सारे question में guys ये भी पूछा जाता है that what is the remaining acid? So the remaining acid is this, but here it is not asking you the same thing. Here it is asking you mild base के बाद में what is the where does this amino acid go? वो पूछ रहा है यहाँ पे, right? X. How do I know that? Because they are doing hydrolysis. If they were not doing hydrolysis, तब हम बोलेंगे कि residual amino acid is the product. But then they are doing the hydrolysis. Okay, so that is important. After hydrolysis, what do you get? After hydrolysis, this amino acid is going to eliminate and you are going to look at the options and see कि कौन सा amino acid connected है. So this one is connected, this is correct, and also what are you going to check guys? The configuration must not change. ठीक है, configuration must not change over here. So what is this? It is 1, 2, 3. 1, 2, 3 anti-clockwise, it is S. And what is this? 1, 2, 3, once again it is also S. मतलब configuration change नहीं होनी चाहिए, S का R नहीं होना चाहिए, right? That you must be careful about. So A is the correct answer. चलो, we move onwards. And guys, yes, before moving onwards, let me quickly remind all of you कि Unacademy Lite subscription जो है, you are getting that subscription in for 6 months in 269 rupees. So 6 months के लिए all the test series, question bank, previous year question paper of Unacademy will be available to all the students who are having this Lite subscription. Okay, don't forget to use the code that is Jagriti S Live. ठीक है गाइज, अभी 6 मंथ के लिए आपको बहुत कम में सब्सक्रिप्शन मिल रहा है एंड इट इज बेस्ड फॉर द ओनली द टेस्ट एंड द प्रैक्टिस, राइट? एंड ऑल्सो फॉर दो स्टूडेंट्स हु आर वेटिंग फॉर अनअकैडमी प्लस और आइकॉनिक टू ज्वाइन गाइज, नेक्स्ट सेशन के अंदर हमेशा प्राइस हाइक हो जाती है. So join before the price hike. This is what I want to say to all of you. एंड कोड आपको पता ही है. और अगर आप प्राइस हाइक से पहले ज्वाइन करते हो तो आपको एक और प्रैक्टिस कोर्स मिल जाएगा विच इज एडवांस प्रैक्टिस कोर्स फॉर CSIR NET 2022. आपके एग्जाम से पहले 21 सेशन हो रहे हैं विच इज कंप्लीटली बेस्ड ऑन प्रैक्टिस. ओके, सो यस, डबल बेनिफिट. ओके, चलो. If you have any query, then you can ask me on Telegram. Also, आपके notes आ गए हैं on Unacademy. That is, in-app notes are already available, and more of the notes are getting added. So, for the iconic learner, hard copies are available, and for the plus learner, in-app notes are available. So, आप देख लीजिएगा वो भी. Okay? चलो guys, let's move onwards to the next important question. The correct order of carbonyl stretching frequency of these three or four molecules in the IR spectrum is. So you have to compare, guys. And this is a evergreen question which is being asked plenty of times. Carbonyl stretching frequency based on the pi acceptor or donor property of the phosphine. ठीक है? Yes, everyone. All right. Okay, very nicely answered, everyone. Chalo. So what is happening over here, guys? The carbonyl frequency, and first of all, even it is mentioned or not mentioned, you are going to consider Ma3B3 type complexes as facial isomers, isn't it? इसमें बोला तो नहीं है. Question has not specified that, but you are going to consider the facial isomer. Why? Because then only all the carbonyls, let's say, all of the carbonyls are going to be, yes, all of them will be facing the phosphine, whatever is the phosphine. All of them will be facing the phosphine. Then only they will have a direct effect on the carbonyl stretching frequency. So as you can see, guys, if the R group is having a plus I effect, if the R group of the phosphine has a plus I effect, phosphine becomes a strong sigma donor, and it is going to cause a lot of pi back bonding to this carbonyl. The stretching frequency decreases. So as the plus I effect increases, stretching frequency decreases. तो हमें क्या करना है, यही देखना है that chlorine is the most electronegative as compared to oxygen. Okay, oxygen is not as electronegative, guys, but see what happens is oxygen is connected to one phenyl ring. So the charge also delocalizes into the phenyl ring. So absolutely not that electronegative as compared to this chlorine. Then there is methyl which is having a plus I effect, and nitrogen to acceptor hai hi nahi, it is only a strong donor, absolutely lowest value of carbonyl. So plus I effect of the R group increases, carbonyl stretching frequency decreases due to pi back bonding concept. Yes, chalo. Let's move onwards. Next question, guys. Designate the following complexes X, Y, and Z as inert or labile. Another very important category of question on inertness and lability हमेशा आता है. Yes, so what do you think is the answer? Yes, all of you. All right. So, why should I say that X is labile? What is the order? What are the factors for inertness and lability? इस पे तो +2 charge है, इस पे +3 charge है, and the aluminium is also having a +3 charge, guys. Yes. So based on the charges, I must say that aluminium is labile. इतना high charge है, how is it possible कि ये labile है? तो inert होना चाहिए. But it is still more labile. It is still more labile as compared to वेनाडियम 2 प्लस एंड क्रोमियम 3 प्लस क्योंकि ये दोनों क्या है ये दोनों D8 है yes both of these are D8 electronic configurations which are absolutely inert and if you have the comparison कि वेनाडियम और क्रोमियम में से कौन ज्यादा inert है then chromium is going to be more inert yes अच्छा सॉरी हाँ D3 क्या बोल रही हूँ मैं D8 नहीं D3 okay yes and if there is a comparison. Alright guys, yes. And if there is a comparison that which is more inert then chromium 3 plus is more inert because of the high charge. ठीक है? चलो. Yes guys, D3, absolutely D3. Okay, so we move onwards and we do another important question. In the reactions of D-glucose, ये एक question है जो हमेशा same आता है that D-glucose or mannose or fructose whoever they are going to be protected by acetone and PHCHO. This is very scoring. You just have to know what you are expecting from here. Yes, what is the major product? Yes, प्रतिभा सी बोल रहे हो अच्छा एक बात ना हमेशा when the comparison is asked about the acetone and aldehyde you will always see that acetone will protect the 1,2 diol जब comparison हो रहा है तब and the aldehyde will protect the 1,3 diol ठीक है what is the structure of glucose I'm writing the open structure okay yes so this is the open structure of glucose for the protection of 1,3 diol आप आराम से 6 membered ring बना सकते हो what is the 6 membered ring guys when this last oxygen when this particular oxygen is forming the hemiacetal with this CHO that forms a 6 membered ring ठीक है you will end up with 1,3 uh, 1,3 diol like this see this is 1 and 3 diol ठीक है तो 1,3 diol को इसलिए protect करता है so that there is minimum 1,3 diaxial interactions इसीलिए so always whenever aldehyde benzaldehyde or whichever other aldehyde is there ठीक है तब क्या होगा it is going to protect the 1,3 diol and it is going to form the uh, decalin type system ठीक है A is correct this part is correct okay but ये जो A है इसके अंदर ये wrong हो गया this is wrong why because whenever you're having acetone you cannot protect the 1,3 diol so that you cannot do so because then it causes 1,3 diaxial interactions like this अब ये मिथाइल जो axial है वो 1,3 diaxial interaction बना रहा है तो A तो गलत हो गया Yes. So we have the same possibility in option number D. ठीक है. This part is correct. What about 1,2 diol? So for the formation of 1,2 diols, please just take this OH on the 1, 2, 3, 4. Fourth carbon. इस OH से hemiacetal बनाओ. You will get a 5-membered ring. In that 5-membered ring, you will have these two diols which are free to form the hemiacetal from the acetal with the acetone, and the diol which we get over here. तो ये दोनों और ये दोनों ये bind हो जाएंगे. ये देखो, these two, all right, and these two they are binding with the acetone. और एक ये वाला OH जो है ये free रहेगा. This is the one OH which is free. So you have identified this. बस काफी है. D is the correct answer. ठीक है. All right. So see, you have understood the possibility 1,3 diol, 1,2 diol when you have to form. According to that, you can form the furanose type of ring or the pyranose type of ring, right? So D is the correct answer for this. Let's move onwards. Next question, guys. Reaction of meta methyl anisole with lithium in liquid ammonia and tertiary butyl alcohol at minus 33 degrees centigrade generates a compound X as the major product. Treatment of the compound X with dilute sulfuric acid produces Y as the major product. The compound and X and Y respectively are. Yes, Pratibha, last question का आंसर है ऑप्शन नंबर डी. डी करेक्ट आंसर है इसका. ठीक है. So yes, guys, what is metamethyl anisole? It is anisole is this one. Meta position पे there is a methyl. So how should it be? Birch reduction हो रहा है, isn't it? Yes, simply birch reduction. So yes, guys, एक बार फिर से consider करो. Birch reduction is the product. Okay. Birch reduction is the reaction. How is the electron transfer going to be? Electron transfer takes place in such a way that both of the electron donating groups are not having electrons. तो ये reduction ऐसा होगा, 1,4 reduction. Yes, it is going to take place like this. Absolutely. And then what happens? Yes, so it is correct in C and it is also correct in D. दोनों में सही है. Yes, option number A is wrong, option number B is wrong. So till here it is easy. What happens in the presence of an acid? In the presence of an acid, yes, the oxygen, this oxygen over here, what is it going to do? Use the lone pair and grab a proton. उससे क्या हो जाएगा? ये देखो, ऑक्सीजन मिथाइल पॉजिटिव चार्ज, यहाँ पे प्रोटॉन्स आ गए हैं, and the water can now attack this methyl which becomes free. Okay, so हमारा कीटोन तो ऐसा आना चाहिए. This is your ketone, but ऐसा तो है नहीं. We don't have any such thing like this. So guys, please be careful in the presence of an acid. In the presence of an acid, you are going to form an enol. In this case, वो enol ऐसा दिखेगा कुछ. OH, one double bond, another double bond is already present. Now this enol is going to cause tautomerism, but till this carbon. So finally, after the isomerization step, your molecule looks like this. तो इसका आंसर क्या होना चाहिए? ऑप्शन नंबर डी. C is wrong. क्यों wrong हो गया C? Because the double bond should be on the more substituted side. alpha beta unsaturated, but that also more substituted alpha beta unsaturated. इसलिए D आंसर है. Okay? Yes, absolutely. So be careful in this thing. Okay. Next question. ये देखो बहुत easy है. In the reaction sequence, you have this molecule, you have LDA 2 times. Yes, guys, what is this question? Selectivity का question है, directly Caruthers से उठाया gate ने, right? So, yes, what is the product? Yes, guys, what is the correct answer for this particular question? Very, very important question. See, the formation of enolate and the reaction of enolate and its stereochemistry, all of these things are involved in just one reaction. उसके अलावा भी एक और reaction है, heteroatom oxidation followed by syn elimination. कितने सारे concept एक ही question में. ये देखो. So a proton is going to be removed from here and you are going to form the enolate. How does the enolate look like? See, both the hydrogens are above, so I am just going to write the enolate of the ester, lactone ka enolate hai in this place. The hydrogens are above, which means which means the ring is actually like this, right? And the above phase or the concave phase, this is the less hindered phase. तो अब यहाँ से PHSeCl को attack किया, Cl minus gets removed. Where are you going to get the SEPH group? Absolutely above the plane. ये hydrogen है, इधर भी hydrogen है, and this molecule ends up above. First step में it is going to be above. Yes, first step में it is going to be above, लेकिन फिर से enolate बनेगा. Second step में देखो फिर से enolate बनेगा. So when you are forming the enolate once again, guys, then you have to be really careful about this, that when the second enolate forms, the SEPH group, now it is planar. Alpha position पे enolate बन गया तो ये planar हो गया फिर से. Again it is planar. And again you are having methyl iodide. So methyl iodide के लिए this methyl will be attacked once again from above. Methyl will be attacked from above, और जो existing group है, this will go below. ये देखो, this will go below, methyl is going to come up above. That is the question. This part is correct. ये वाला गलत. B and D are wrong. This part is correct in A and C. Yes. Now what? अब यहाँ तक हो गया ठीक है, no problem. But what after this? After this we will see what is the next reaction. इसके बाद में क्या reaction है guys? इसके बाद में है heteroatom oxidation. That is oxidation on the selenium. ऐसे double bond हो करके. So since the selenium is below the plane, you cannot remove this hydrogen because it is above, selenium below है. तो क्या करेंगे guys? You will remove a proton from this particular methyl और methyl से कर देंगे syn elimination to give you this molecule. This is not possible because the hydrogen is above and selenium is below. So A is the correct answer. Absolutely. Yes, very 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 important question. बहुत अच्छा question है ये. चलो, let's move onwards. Last pair of question. Now this is a pair of question that you have. Last question है ये आज के session का. Common data for question 51 and 52 is, ये देखो, treatment of hexacarbonyl tungsten with one equivalent of Na C5H5 in THF solution give the ionic compound M. Reaction of M with glacial acetic acid result in the product N. The proton NMR spectrum of N displays two singlets of relative intensity 5:1. When N is heated, hydrogen gas is evolved and the oxygen is produced. Oxygen may be prepared by refluxing the initial compound with cyclopentadiene and H2 is also produced. Treatment of oxygen with an equivalent bromine produces P. So guys, काफी लंबा चौड़ा question है ये, but I hope you will be able to do this. Yes guys, एग्जाम में करना है तो यहाँ तो करना ही है. Also use 18 electron rule as your guide. So always whatever complex is forming that must follow 18 electron rule. यही बोल रहा है question. Yes, so पहले ये बताओ what is M and N? Okay, मुझे तो clear दिख रहा है guys. Alright, चलो. I'll write the whole thing for all of you. Although I can see it very clearly. Yes, so what is asked? That is, you are going to have this complex NaCP. That is Na positive Cp minus. Now, tungsten hexacarbonyl, this is already following the 18 electron rule. Already following the 18 electron rule. So, if this complex has to react, तो इसको क्या करना पड़ेगा? It has to make space for the Cp. So let's say what is it doing? इसने क्या किया? -3 carbonyl it did. Let's say you are writing W eta 5 Cp क्योंकि ये जीरो ऑक्सीडेशन स्टेट में है. So CO whole 3 there will be a minus plus 3 carbonyls. 3 carbonyl have to be replaced. Now if you find out the 18 electron through the 18 electron rule, tungsten has 6 electron plus 5 plus 6 plus 1. This is an 18 electron species. ठीक है, और ये हो गया compound M. This is compound M. Reaction of M with glacial acetic acid. Guys, who is having the minus charge? Minus charge किसके ऊपर है? Absolutely tungsten के ऊपर है. Yes, tungsten के ऊपर minus charge है. So what can we do in the presence of acid? We have this C5H5, 3 carbonyls, और क्योंकि माइनस चार्ज था उसने एक प्रोटॉन ले लिया. So there is a hydrogen over here. This is your N. तो reaction of this products give N. ठीक है, तो N का प्रोटॉन NMR क्या है? देखो, displays two singlets of relative intensity 5:1. So because of the ring busing, cyclopentadienyl के सारे प्रोटॉन सेम resonance देने वाले हैं. Yes, all of the 5 Cp protons are going to give you the same resonance, and there is one singlet over here, two singlets of 1:5 intensity ratio. This is your molecule N. तो कैसे देखेंगे guys? देखो, yes, look at this. It is also correct and this is also correct. So answer is option number A. इसका आंसर है option number A. The compound O and P respectively are now still moving onwards. You have this is heated N is heated, hydrogen gas is evolved and oxygen is produced. तो अगर यहाँ से हीट करके हाइड्रोजन निकालना है -H2, then what should happen? हाइड्रोजन तो एक ही है ना. रिडक्टिव एलिमिनेशन इज नॉट पॉसिबल. वी माइट डू वन थिंग कि हमने हाइड्रोजन एलिमिनेट करने के लिए एक टंगस्टन टंगस्टन का बॉन्ड बना दिया, like this. Tungsten tungsten bond formation takes place. This is possible, isn't it? Yes, absolutely this is possible. Count the number of electron, guys. अभी कितने electron है per tungsten? So tungsten has 6 electrons. 6 plus 5 from the Cp is 11. 12, 13, 14, 15, 16, 17 and 18 for the metal. Absolutely ये भी 18 electron follow कर रहा है. Correct. So it is a dimer which forms. Now, treatment of oxygen with one equivalent of bromine produces P. So react this with bromine. You are once again going to break the tungsten-tungsten bond. And what is the formula, guys? ये देखो C5H5, एक tungsten, 3 carbonyl and a bromine. Absolutely, A is correct once again. Dimer formation by heating. Absolutely, Ibu. And everyone, guys, you have answered very nicely. Organometallic questions are very scoring. And whenever you see a question this big, ये हमें demotivate नहीं होना है. बहुत simple सा question है. We have to crack this, okay? Yes, so this was the last question that we had done in today's session, guys. And since this is only the first session and we are going to do more important question, we are going to do 70 questions in total, which means बहुत सारे session होने वाले हैं. ये देखो 70 important organic and inorganic question. The timing is 6 p.m. now. New timing for YouTube, Thursday, Friday and Saturday. Okay, so yes guys, I'll see you all over here only. और बैटल ऑफ पोल स्टार्ट कब से हो रही है? 4th of September से. Starts from 4th of September. So what you have to do is just visit my profile and register. And for those interested in joining an Academy Plus or Iconic or Light subscription, don't forget to use the code Jagriti S Live before the price hike, क्योंकि price hike कभी भी हो सकती है, मुझे भी नहीं पता कब होने वाली है. Okay, चलो. So yes everyone, keep practicing and I'll see you very soon. Bye guys, take care all of you.